Before I get started with this video, I just wanted to say thank you guys so much for 100 subscribers. I never thought I would make it to 100 subscribers, and it means the absolute world to me. So thank you to every last one of you. I'm feeling a bit controversial today. Did you know that 0.9 repeating is equal to 1? It's not really close to 1. It's not almost 1. It is in fact equal to 1. 0.9 repeating is a different orientation of 1. It is a form of 1. They are equivalent. Apparently, this upsets a lot of people, and I'm not here to upset anyone, so you have been warned. The assertion is that 0.9 repeating is equal to 1. This can also be written as a summation. So this right here says that if I take numbers starting at 0 and plug them in for k and then add them all together, I'm going to get this repeating decimal 0.9 repeating. Allow me to begin the summation as follows. I'm going to take 0 and plug it in for k. If I plug in 0 to our function for k, I'm going to get 0.9 as our first partial sum. Working our way up the counting numbers, the next number in line to be plugged into the function is going to be 1. So if I plug in 1 to this function here, I'm going to get 0.09. That's going to be our second partial sum. As for our third partial sum, I'm going to plug in 2 to our function. So where there's a k, there's going to be a 2 there, and I'm going to get 0.009. And for our fourth partial sum, I'm going to plug in 3 to the equation. If I plug in a 3 up here where the k is, I'm going to get 0.0009. So here I have the first partial sum, k equals 0, second partial sum, k equals 1, third partial sum, k equals 2, fourth partial sum, k equals 3, and I would continue on following this trend. Another way that we can write 0.9 is 9 over 10. Another way that we can write 0.09 is 9 over 100. Another way that we can write 0.009 is 9 over 1000. Another way that we can write 0.0009 is 9 over 10,000, and so on. Repeating decimals can be defined as geometric series. I did a video on geometric series previously where I was a little bit more thorough with my definition of it, but for the sake of this video, I'm just going to write out the definition for it mathematically. A geometric series can be written as a summation. We have the summation of k equals 0 to infinity of a times r raised to the power of k such that a is not equal to 0 and r is a real number. It's within the reals. The convergence is when the absolute value of r is less than 1 and it converges to a over 1 minus r. If you're wondering what a convergent series is, it's an infinite series that has a finite sum. It converges to a specific value. In other words, a sequence converges if its terms approach a single finite number as n approaches infinity, or in this case, as k approaches infinity. But the condition for convergence for a geometric series is that the absolute value of r has to equal less than 1. Let's take a look at our theorem here. A is equal to 0.9. R is equal to 0.1. Everything else is relatively straightforward because it's literally the same. K equals 0, and k has the exact same placement over r. Upon establishing these common definitions, I will proceed further by proving that 0.9 repeating is equal to 1. Using this theorem, we can see that a is equal to 0.9, and 0.9 is the same thing as 9 over 10. As for r, which stands for the common ratio, we see that r is equal to 0.1. Therefore, r equals 1 over 10. And the absolute value for r is equal to 1 over 10. Well, 1 over 10 is in fact less than 1, so this checks out. This means that the series converges. But do you know what's crazy? If the series converges, that means that it settles to one finite number. And you know what's crazier? We have the formula right here to find that finite number. So let's go ahead and find it. Since 1 over 10 is less than 1, that means that a over 1 minus r will reveal to us what this series converges to. A is equal to 9 over 10. We have 9 over 10 in the numerator, and in the denominator, we have 1 minus r. R is set to 1 over 10. Let's rewrite 1 as 10 over 10. 10 over 10 is a form of 1. We rewrite 1 as 10 over 10 so we can subtract 1 over 10 from it. At this point, we can see that 9 over 10 over 9 over 10 is going to equal 1. But if we really want to, we can reciprocate. I really want to. 9 times 10 is 90. 10 times 9 is 90. 90 over 90 is a form of 1. This series converges to 1. Therefore, 0.9 repeating is equal to 1. Thank you for watching my video. Have a good day.